right, so I guess we will start. Hello everyone, I am Mihaela. I am a software architect at Systematic. This is a Danish company specialized in building software for critical domains, such as the Defense Department, which represents the business units for which I'm working, but we also have others, healthcare, security risk, and many others. But here today I'm going to present one of our functionalities, one of our main applications, heavily used by our customers, especially when it comes to editing documents, military documents in the same time. But I'm going to present all the details shortly. As more and more organizations have moved all of their workflows and data online, including those from the military domain, so they don't represent an exception for this, the expectation was that everyone can work together in real time, and as mentioned, especially when it comes to editing documents at the same time, all at once, and see each other changes. As such, we were in the position of having to build a solution similar to Google Docs, but embedded into our own application. And we also had to build a lot of layers of security on top of it to fit the domains. And today, in the next 40-45 minutes, I'm going to present how we managed to achieve this. And I will start with a very short introduction, a brief overview of what exactly were our operational needs, which gave the complexity of the task for us, so that you can understand why we made certain selections, certain choices on the technical side. Afterwards, let's see what exactly is a rich text editor in the context of the military world. What is the collaborating editing itself, and what was the solution that we ended up implementing for this part. And lastly, a lot of requirements that we had to build on top of it, especially on the security sides, and I will show you a couple of them. So let's get started. And I already mentioned, and I will repeat myself, our main customers are them. So we are building software for these guys, and the last two screenshots from below contains some images from our own applications, so that is the software installed on their devices. Well, the important part is that they work either on land, on sea, on air, or just from a centralized command and control server, from where they operate all of their military operations. But what they all have in common is the fact that in a military operation there are a lot of phases, including the planning one. And for the planning one is for which we have built that collaborative text editor solution. Because in that planning operation, there are users or units, how we call them, from a lot of organizations. Can be one, can be multiple, can be allies, can be organizations that they collaborate just for a specific military operation. And it is important that they can all get to work together in this planning phase of the operation and edit a lot of military documents all at the same time and see each other changes. That's something really important, because these documents can contain a lot of information about logistics, about holdings, about the organizational itself, which units needs to do what specific operations. And for this purpose, they need to access the same document. They need to make changes. And that's not the only part here. Because they are a lot of units from a lot of organizations, most of them have different ranks. And these ranks translates into security clearance levels. And this means that we need to restrict their access either on the document itself, so not all of them should access the same document. For example, if a commander mentions some specific instructions for a battalion, someone from another unit that is not a battalion shouldn't access that document. And it's not only the document itself, as that can be easily achieved with some privileges, some roles, but we also had to redact the documents. Because, for example, there can be portions of that document, some paragraphs over there, that can be restricted to some specific user. And if, for example, someone tries to print that document that doesn't have the necessary clearance, well, we had to redact the document. And let's see how we managed to achieve this. And I'll just briefly show you another requirement for this to complete the full picture of our operational needs. I mentioned that there are a lot of units, a lot of users from different fields, different ranks, translating into different security clearance levels. But they can also be on the same level of our applications. This is just an example of 6.18 version of ours, but they can also be on different versions of our applications. And more than this, on top of this, the application itself can be deployed, so it can be installed and used from different sort of devices. It can be a PC, it can be a tablet, it can be a mobile, or it can be just a device from a tank, for example. What is important, or from cloud. I do have a cloud over there. What is important is that they should all access the same document at the same time, no matter the version, no matter the application, and be able to see each other changes in real time. And because we are speaking about the military domain, we are mostly speaking about air-gapped environment, meaning no internet. For example, if they are on the field, one of them is going behind a hill, they are not in the same proximity, so most probably it won't have the connectivity to access the document. But when he will be back, he or she will be back online, he should be able to access all the documents. So mostly, this was all the requirement that we had to take care. And therefore, our conclusion was that we need to build a collaborative text editor embedded into our own application. We couldn't just tell them, use Google Docs, that's not ours. We needed to provide something of our own. And we needed to ensure that we still follow our high standards of performance, quality, and most importantly, security, especially for them. And especially for those documents, because they don't want people to access something that they are not allowed to, and we had to ensure this. Okay, but before we jumped into the implementation phase and say, okay, we know how to do that, let's start implementing, we had to define what are the concepts involved in this whole process. What are the requirements, to make a list of those requirements, and in particular to break down that use large case that sounds, okay, we need to build a text editor. Let's try to build into smaller, multiple and smaller use cases and see how we are going to address each of them. And to define that context, to define those concepts, we first started with the first question, what exactly is a rich text editor? And here, I would say that a rich text editor first is defined by an ordered list of characters, and each character has a value. It can be a letter, a number, a space, or anything else, any other kind of similar symbol, and an index, which represents the numerical position of that characters inside that ordered list. And what can we do with those characters? Well, we define some basic operations, inserts and deletes. And if you are wondering why the updates aren't there, that's because an update is actually a delete followed by an insert. For example, if we want to replace, instead of rest, to have test, that R replacement is actually not an update. We delete R and we insert another character over there. But obviously we wanted more than this. So we made a list of some advanced operations. We wanted our users, and they wanted as well, to be able to apply a lot of styling formats. So everything that you see in Google Docs, in Word, and any other similar editor, to apply bold, italic, font color, font text, and so on. You have a couple of them from our application there. More than this, we wanted the ability to manipulate, to work, to insert, delete, and so on, advanced objects, how we call them. Tables, images, videos, links, horizontal lines, and a lot of other similar objects. And because I did mention several times about those ranks of our users, we inserted something called classification. And this classification is our data model for handling those security clearance levels, both at the text editor itself and inside it at the paragraph level. And with these requirements, plus the collaborative editing in mind, I will get to that part. There is a lot to talk over there. We started to look at the available frameworks on the market. We said that definitely we are not the first ones trying to do this. There should be something already available on the market. And we did look at a lot of them, and I only have a couple over here. So Froala, CodeMirror, TinyMCA, CK Editor, and a lot of many other frameworks. But at the end, we ended up with Froala and CodeMirror, and we have a combination between them in our application, and we built on top of it. Have you heard or worked with them? No? Nobody? Oh, okay. There are a few in the back that work with these two, or at least one of them. Well, let's see why. Why we ended up with Frontmania and CodeMirror. The reasons were also technical, but not technical. First ones were something that were above us. So someone from our team had to look at the licensing plan for this. And that's because most of the frameworks available on the market have that collaborative editing price based on the number of installed machine servers. And that's an unrealistic task for us. We couldn't ask our customers provide us the number of servers or devices where you are going to install the application and from where you are going to use that collaborative text editor. If they are on a field, for example, and some Alice joins, if they paid for 234 licenses, the other 10 or how many they can't say, you can't work with us because we don't have license for you. So definitely we removed from the list everything that had this, and there were plenty, all of them, because the collaborative part is quite heavy to implement, so we understood the reasons behind the framework suffering this, but we couldn't accept them. Afterwards, we looked at the support cost, because we have heavy customizations that we require quite often to get support from them, and this was an important factor as well. But more than this, some of them were forcing us to share our code to the community. And while this is something nice to have and something that to share to the community and get feedback and collaborate, we can't do that with our code for the defense domain. Not even inside our own company, people from other departments, for example, from healthcare, can't access our code. So we definitely couldn't share this to the community. So we removed a couple of other frameworks for this. And two other important parts were that some of them were not even maintained or had a frequency of generating new releases that were not accurate for us. If something wasn't touched for 2 years, we didn't want to work with that. And lastly, it was on the technical side for our application, for our own application, the compatibility of those frameworks with what we had. Because some of them only were supported with React, and we worked with Angular. And we weren't willing to change our entire client architecture just for one functionality, and not even to do some workarounds to make them work and maintain them hard in the future. So we ended up with Frontmania and CodeMirror, but only for the rich text editor side. So for those little operations that I mentioned above, to be able to apply format, to be able to work with some objects. For example, from CodeMirror, we have the stylings. From Frontmania, we have the objects, tables, links, and so on. But we still needed the collaborative part, and that is something that we had to build ourselves. This was the conclusions. But what exactly is this collaborative editing that I'm mentioning about? And to have some sort of a definition, I would say that it involves users from multiple places that work together on the same document at the same time. But that's more. It means that we also have, if this wants to display, we also have a local copy of the document for each user, so something that each user can access on their own local browser, can make changes, but at the end, those changes should be sent to all the others. All the other users must see in real time those changes made by someone. So this is how we define the collaborative editing part. And obviously that's more, because we started to look at solutions. So how the solution for a collaborative editing part looks like. And we started looking at how Git works, because this is what we were using. Are you used to Git? Work with it? Heard of it? Everyone, perfect. Then I'll quickly go from how would our solution look like if we would have followed the principles of Git. And let's assume that we have a file. So let's say version 1.0. 2 users, each of them with its own local copy. The first user, let's assume that this one writes a bit faster, it's quicker. So his changes will go first. He will commit those changes, and we'll end up with a file version .20. What happens with user 2? He will make the changes, but let's assume that at the exact same location as user 1. And when he will try to commit and merge them, well, he or she will get into conflicts. This means that she or he will need to manually resolve those conflicts, commit the changes again, push the changes. That's the process that we all know with Git. Well, but if we were to follow this approach with our collaborative text editor, it means that our users would be interrupted quite often, every minute, every second, to manually resolve changes, and we didn't want this. If we were using this approach, then our application definitely would have been unusable by our customers. So we had to figure it out something else. On the other hand, we can think that conflicts only appear if we were to make changes at the exact same location in the document, and maybe that's not that a common scenario. Maybe it doesn't happen that often. But what if, when this happens, we wouldn't be prompted by those conflicts to manually resolve them? What if the system, the application, the software behind it would automatically do its best guess and fix those conflicts automatically for us? And in case it guessed wrong, then one of us could fix it manually. And maybe you are thinking that what I just said sounds wrong. And in theory, I totally agree. In theory, it sounds wrong. But in practice, it works. It quite works. And that's because the system doesn't necessarily need to be right all the time, but it needs to be consistent. And it needs to keep up with the user intent of what exactly he wanted or she wanted to do with that document. And well, this is the approach that we started to follow. And let me show you how. Because at this specific moment, when we said that the system, it doesn't matter how it resolves those conflicts, it matters to be consistent and to keep the user intent. At this moment, we define the collaborative editing by two keywords: consistency and responsiveness. And I will start with the consistency part, because I will show you now. Let's assume again that we have two users, those two from earlier, user 1 and user 2. Initially, we have an empty state of our document for both of them. Let's say that the first user types in the word collaborative. So the intent of the user was to have collaborative in the document, and this is what the document should show at the end, the collaborative word. What happens when user 2 decides that, well, I want editor to be in that text document? So the user intent must be kept as well, and we should end up eventually with the word editor. But as mentioned, we are working on the same document, and they are working at the same location. First line, first character from that document. So eventually, we need to have the same text for both of them. And at this moment, it doesn't matter if we have collaborative editor, as I mentioned, or we have editor collaborative. The important part is to have the same version. Sorry. It is important to have the same version in all the similar situations. So we wanted our editor, in this case, to be consistent, to not prompt for conflicts. As mentioned, we don't care if it's collaborative editor or editor collaborative. We do care that it is the same all the time for this sort of situations. And we need people using it to be able to access the changes when they take place. And this is the responsiveness part. And here we were wondering how exactly would a solution for the responsiveness look like. And let me show you, because once again, we looked at Git, and in particular at Git diff. And we have here an example, an illustration. And we said that, okay, if we were going with this approach, we would end up with something like this. At line 1, this text was changed from this to this. But it's a bit hard to identify what was the user intent with this, what exactly had to happen. So we said that this is not the right approach. And we continue investigating until we define some sort of objects called operations. This is how we name them, and you will see why. Operations or actions, where we have a couple of information. So first of all, we have the type of action that took place and which represents the operation that we talked about earlier. Either it's an insert or an update. Afterwards, we have the position in the text document in that order list of characters where that action takes place. And lastly, we have the text, currently the text. Further, we will see how it looks with objects. We will have the text that was, in this case, inserted in our document. And for one user, it will look something like this. So from collaborative that we have in the document, the user tries to do an insert at position 14 with the word editor. And obviously, we will end up with collaborative editor in our document. But let's see what's happened when we have two users, because this is from where we started. And let's assume, to simplify things, that both of them have collaborative in the document at moment T0. And the first user tries to insert editor at position 14. So at this moment, on his local copy, we will have collaborative editor in our document. And with that operation, that object that we have defined previously, we will send a notification, so simple notification on topic. And when we will get an insert editor at position 14 for user 2, we will end up with a collaborative editor. So everything looks fine. No? Do you agree? Okay, so at this moment, we sort of have something that looks at a solution. But only user 1 was making changes. User 2 was staying there patiently, doing nothing, didn't touch anything, didn't break anything, and the notification just came and it was applied, and we do have a consistent document. But what happens if we have the two users making changes at the exact same time? And let's dig more into the consistency part now. And I will start with this. So let's assume that at this moment we have A and T for both users. User 1 with red will insert C at position 0. So he or she wants to type in a cat in that document. Looks okay so far. Let's see user 2. User 2 tries to insert an R on position 1. So he wants to end up with art in the text document. What happens when we receive the notifications of each other changes? So when we receive at user 2 the notification from user 1, meaning to insert C at position 0, we end up with a card. This is what user 2 will see in this document. On the other side, when the notification from user 2 will be received by user 1 local copy of the document, we will end up with a CRUT, because here we have said, okay, insert R on position 1. And this too doesn't look the same, no? And I even don't know what this is, but definitely not the user intent. So at this moment, our consistency rule is broken. So our solution is not perfect. This is for an insert. Let's see what happens for a delete. We have cat, as we seen earlier. First user wants to delete the first character at position 0. Second one will do exactly the same. So at this moment, before getting those notifications, both of them will see AT, but those notifications will go through and they will end up with a T. So they will delete more than they wanted to. So once again, our consistency rule got broken. Therefore, there are other things that we need to consider to make sure that our document is consistent. And those things are represented by some basic math stuff, commutativity and idempotency. Commutativity, we all know what this is. The same operation should produce the same results regardless of the order. And we have the sum example. A plus B is equal to B plus 1, B plus A, sorry, no matter what. And the other operation, idempotency, means that if we apply repeatedly the same operation, it should produce the same results. It's like multiplying A by 1 multiple times. We can't get a B over there or something else. So one of the solutions to address all of these problems with the consistency, taking care of these two as well, is represented by something we called operational transformation. And this is purely an algorithmic solution with a lot of rules, and this is what we ended up implementing for a couple of releases. Because there are a lot of scenarios. If someone inserts something in the middle of the string, applies a font, and inside that font text applies underline, and inside that underline text color, and so on. And we needed to take care of these algorithmical problems. And with this in mind, let's see exactly how this works and how it helped us solve our previous problems. Because operational transformations, as the name is, they are based on a set of operations. And these operations are purely algorithms that transforms those operations into something else prior to applying them on those local copy of the documents. And they relies mostly on the numerical indexes for the positions of the characters inside that order list that we defined the text editor at the beginning. And let's see how this is applied and how it transformed those operations prior to applying them. Let's return a bit to the previous example. So we had A and T at some point. First user inserts a C, we end up with a cat. Second user inserts an R, end up with an art. Now the notifications part. Previously, here, we were saying that insert R at position 1, because this is what user 2 did. But we started to look at the indexes. What was the user intent? R to be inserted before T and after A. And we started to look at the indexes of these two characters, and we ended up with saying that actually we should insert R at position 2, because that's right between those characters that the user intent was from the very beginning. And the same applies for the other operations, only that here it's a bit simple. Insert C on position 0. That's right before A, nothing before that, so this is exactly how we transform the operation before sending it. And now the document is consistent. What happens with the idempotency part for the deletion? So we have cat for both of them. We delete the first character. The second user does the same. And when we get to the notifications part, the operation is already applied. So once again, we look at the position of the characters. What we wanted to delete is a C before an A, nothing before that. And when we compare the two notifications that came, we identified that they are actually the same. And we didn't do anything with them. We just skipped them. And once again, we have a consistent document. And once again, as earlier in the example that we saw a couple of minutes ago, we are in the position of saying that we have a perfect solution, and that's it. We have our collaborative text editor. But we did have a couple of requirements that required some adjustments to our solution. And let's see a couple of them, because some of them transform into some challenges. So we had to find some solutions to work around some of them. And the first one, I mentioned a bit at the beginning about this, is the fact that we need to work with advanced objects, how we call them, formats and objects. This means that we want lists, we want headings, we want horizontal lines, we have links, tables, images, videos, and also some links to some of our other internal functionalities from inside the application. And you see there are a couple of examples from our text editor. And let's see an example to see why this was a challenge. If you remember the scenario of the two users, the first one typed in item 1, the second user item 1 and item 2. So far we do have a solution just from the text part, and we will end up with the same consistent document, item 1 and item 2 at the end. But item 1 is being formatted to be a list, and user 1 decided that this will be a bullet list. User 2, on the other hand, applies a list as well on his item 1 and item 2 list, but as a numbered list. So what we will end up with? A combination of the two, apply the first formatting from the first user, the second formatting from the second user, or perhaps we will end up with just an order list or a bullet list or another solution. So at this moment, we also had to decide how we are going to deal with all of this. And in our situation, the rule was simple: last man wins. The last notification that is being sent, it will be applied to all of them. And if user 1 wants to change it, he will do that manually. And we were able to manipulate a lot for these advanced objects, because we had added some complex data structures, how we call them, and HTML, as being a tree-based language, offered us a lot of possibility, because this means that the DOM is tree-based structure, and it allows you to follow it for those algorithms. And this allows us a possibility of manipulating tables, images, and many, many more. And besides that, we also defined at the end a list of advanced operations. For example, we have rename operation, because the rename operation is actually changing from one format to another one, because we had some special handling rules. For example, if you have a list and you change it to a heading, you won't end up with both of them. So if you have an operation of type list and select an operation of type heading, this will replace the other one. And it's just a matter of renaming the operation and visualizing it differently. We also have options to split, merge, wrap, unwrap operations. For example, if you have a paragraph and you wanted to break it into multiple paragraphs, that's also possible. We also distinguished at this moment between inserting or deleting text operations and doing the same with objects. So we ended up adjustment. So we did some adjustments to our object that we previously seen, that operation, and we also had type of objects that we can work with at that moment. And also we have something called marker operations. Because if you want to search something in that document, it should be highlighted. That word should be highlighted in the entire document, so that the user know where exactly are the texts that they search for. And another requirement, because that was definitely not the only one, and once again you see here some examples from our document. Well, users have no idea where to expect changes until they happen. For example, if those two users that work at the same location in the document, okay, they will see what the others do, but they don't know what to expect, when to expect. They don't know that someone else is with them at the exact same line from the document. And with this sort of tooltips, we were able to display the user that is logged at the same document with you, and we are displaying all of them. And we have a lot of colors over there. But at least the users know what to expect, when to expect. And what we did here was related to the cursor of that user in the document that should be visible all the time. And it's not a matter of only displaying it, it's a matter of only including it in our operational transformations. And let me give you an example why I'm saying this. If you remember our cart example from that we saw earlier, I hope it can be seen correctly. With red, we have, let's say, user 1. With green, we have user 2. User 1 with red is right before A with its cursor. User 2 is between A and R. For example, if someone else will insert H at position 1, ending up with the text cart, and the text part, we already solved it, well, the cursor of those two users should remain where they used to be. So if user 1 was just before A, it should end up before A, and same for the other one. So when we did those notifications, we also started to change the position of the cursor. So if there were more than one user connected, we applied operational transformation algorithms on those position of the cursors as well, because they had to remain where they used to be before an action took place. Either that is an insert or a delete. All right, but there's more, other requirements. What if our users accidentally remove everything from that document. We needed operations to undo redo. And that was something simple. We ended up with a stack manager where we stored the invert operation. And let's see what this looks like. We have the same cart example that we kept saying so far. Someone inserts H on position 1, ending up with a cart. What happens behind the scene? This insert H at position 1 operation gets inverted. We store the reverse of it, so delete H from position 1, and we push it to an undo stack. From where, if the user hits undo, we will apply that operation, delete H from position 1, so we will undo the changes, and once again we will save the reverted operation. And that's available for the user session. Afterwards, that's it, no stack manager for those users. And obviously, we do have another requirement. I mentioned something at the beginning. Maybe there are situations where we don't have internet. We lost connectivity, or we simply shut down the application, the computer, whatever we are using. So our changes must be saved if the document happened to close unexpectedly. And for this one, we do have a backend, and we do have a document storage. So we do have the three components as regular applications. So we have our client, we have our server, we have our database. Notifications from the client side are being sent to the server side. From the server side, we store them at the database. And in case something happens, those changes will be pulled from there, and everyone will have access to them. And I think that I will have just one more requirement to show you. If you remember my security clearance level that I mentioned about at the beginning, we had to implement a solution that will deal with classification for our users. This is how we called our data model for this. And let me show you as well a screenshot from that. There are different levels, both the text document itself, that red chip that says res from restricted, that's the naming conventions that we got from our customers, and also at the paragraph level. So there is a heading called restricted information that is displayed with a red triangle, also from restricted. And with this, both at the text document itself and at the paragraph level, we are simply restricting our users from having access to those documents. And as mentioned, no matter what they attempt to do, copy, import, print those documents, everything is being restricted. And it's a simplified version here, but this is something that it will be displayed if someone that doesn't have the confidentiality security level, all the text from that first paragraph will be removed, images, links, videos, and so on, and replaced with a dummy text. This is removed, you don't have the security clearance for this. And lastly, we also have our sharing requirement. And this means that, first of all, we do have multiple users connected at the document from within the organization, the same organization meaning the same application. And all those users do have access to that document, and we have the collaborative part for them. But there's more, because we need some sort of a cluster solution. For example, we can have multiple organizations that join together in a cluster setup, and all of them must be working on the same document with all the rules that we have seen so far. So it's not just a matter of having multiple users from within the same application, from the same installed application on one setup, but we need to allow all of them to do the same. And for this, it was easy to do on the technical side, as we do have some gateways that send the document itself, and the same notifications applies to all of them, but we had to keep backwards compatibility for our data model only for 2 years. Because, for example, if now we introduce a table in the document, support for working with tables, and someone that has a version from 10 years ago, I'm exaggerating, but let's say a couple of years ago, and where we didn't have that table as a data model in our application, they will start saying, I don't see the table that someone from another organization with a better version created, and I don't see it. So we enforced a bit with these rules. And I think that time's almost up. So I will once again show you a snippet from our text editor. And I would like to thank you for your participation. And I think we have a few minutes for questions, if you have some. Yes, please.
Yes, you told us that when there's a conflict between two changes from one user and the second user, the last one wins. That's based on timestamp or?
Yes, yes. So you asked about what happens when we have that rule with last man wins. We do have we based it based on timestamp.
So it has to be all times have to be.
Yes.
Okay.
Yes.
Okay.
Yes.
Second question.
Yes.
Do you also keep the total change stack saved, or do you throw it away?
We throw it away after user session sends. Yes. Yes. It was a requirement from our customer.
Okay, yeah,
and we were happy with that. Okay, thank you. Yes.
So how does it work if a user is like a day offline and has a day offline of changes and throws it to the current document?
We are merging the operations. So you ask what happens if, for example, a customer was offline for 1 day?
Yeah, it's like 5 versions behind or something.
We will pick up the last versions from the database. We have a build all notifications that will pull everything from the database, obviously. And afterwards, we will start comparing all the changes and the timestamps that were on the local copy of the document. And if something doesn't fit what we had, we will skip them. Okay, a lot of questions. Please.
With the deletion example,
Yeah.
you mentioned about checking if the operation itself is the same. My question is, why not check if the response is the same, the result?
Yeah, that's a good question. I think it's the same approach. We end up with the same. So I think it's just an alternative solution to what we implemented. But in theory, I think it's exactly the same. Yeah. Yeah. Thank you. Yes.
What happens if an unauthorized person tries to change something between the authorized things? Will it edit it in between? Will it go to the end?
So what happens if a user tries to do something in the document and doesn't have permission for the document?
Yes, but only at
The paragraph level. Okay, so there are two scenarios. For example, if that user doesn't have access for the entire document, he or she won't see it at all. If it has, for example, confidentiality as a security clearance and tries to do some changes in a mostly restricted document, he will see black sections in the document and can edit before that or after that. Not at the beginning or the end, so before or after that paragraph. Yeah, thank you. Yes?
Since the military usually operates on multiple parts of the world, how do you deal with offline time? Like, time is annoying as hell in normal cases, but how do you deal with synchronizing clocks? Synchronizing, yeah.
Synchronizing clocks, yeah, good question. We do had a lot of problems with that, a lot of them. Because when someone that wasn't online for 2 weeks, for example, we had a situation. Someone wasn't online for 2 weeks, and when he went online, received all the notifications from the others, it messed up initially with the document. And afterwards, we started to try not to look at the timestamp itself or the operation, but also at the operation itself. And we did some merges over there, but we ended up with a notification mentioning that this is our merged version. You need to make some manual changes if we didn't make it work. We did our best with that. Thank you. Yes?
Yes, okay. So regarding the IBM tokens you mentioned,
Yes?
the operations, I understand like those two operations are the same, 0 and 0, but it could have been 0 later on. So how do you really discern whether it is the same operation or not? Do you compare the entire state or?
We compare the text itself. So we have that notification that mentions remove C from position 0. And the other one is delete C from position 0, and they are the same. And we also look at the other character. For example, if we have 3 C and 3 Cs, we do look if you actually remove the other C or the one that was the same for user 1. Yeah, thank you. Other questions? Lots of questions? Okay. Okay, so if there aren't any other questions, then thanks everyone for joining.